Downers. Right off the bat, I can only think of two Cancers. It's the zodiac sign that I've met. And that's this girl from junior high and Carla Pig. But I have concluded through my life that Cancers are depressing. So. I forgot. I can be surprised. I met two Capricorns that weren't very nice. And then I met a nice Capricorn. I was like, wow, I've never met a nice Capricorn before. One of the Capricorns was Mary. I've looked into astrology, read about it and stuff. It's about the gravitational pull of different planets on the Earth at the location where a person is born. And it's sectioned off into 1 or 2 hour time periods, for the time of birth. So it could be, there could be something to it. I printed up a sketch of Ralph Waldo Emerson. And it's going in a special place between the doorways. Hanging solo. I don't have a frame for it though. Que para mí. look up news, see what's going on. Hurricane Elsa is making a threat of significant mudslides in Cuba. Oh. Right. That's really good. the history. Triangle on this possible. Yeah. Big engagement party and then ceremony already. I think Rummy was among the most intelligent in the Reagan administration. Reading an article about Rumsfeld in the Atlantic, how Rumsfeld deserves to be remembered. Quote, Rumsfeld was the worst Secretary of Defense in American history. Being newly dead shouldn't spare him this distinction. He was worse than the closest contender Robert McNamara, and that is not a competition to judge lightly. McNamara's folly was that of a whole generation of Cold Warriors who believed that Indochina was a vital front in the struggle against communism. His growing realization that the Vietnam War was an unwinnable waste made him more insightful than some of his peers. His decision to keep this realization from the American public makes him an unforgivable coward. And then it says, but Rumsfeld was a chief advocate of every disaster in the years after September 11th. So, the whole Surfside building, all the ones, even the intact ones, sections of the building were demolished. There you go. Yeah, I'll have more Kanye. No, but I don't think you're like heroes or anything. Space Mysteries. This is all about Space Magazine. A fast radio burst was detected from within our galaxy for the first time. We may be closer to uncovering its origin. On April 28, 2020, two ground-based radio telescopes detected an intense pulse of radio waves. It only lasted a mere millisecond, but for astonished astronomers it was a major discovery, representing the first time a fast radio burst had ever been detected so close to Earth. Until that point, all FRBs had been observed outside our galaxy. Quote, they've been billions of light years away, making them a lot harder to study, unquote, said doctoral candidate in physics Pragya Chawla from McGill University in Canada. April 2020's discovery was also notable for being the most energetic radio blast that astronomers have ever recorded in the Milky Way, but what made it most exciting is that scientists are now closer to determining the origin of FRBs than at any point since they were first discovered. One of the major problems with detecting FRBs, aside from most of them having been so far away, is that they are so fleeting. They've been gone in the blink of an eye, despite being 100 million times more powerful than the sun. They can release as much energy in a few thousandths of a second as the sun in 100 years. I guess I'm a little confused at what... I thought radio bursts would indicate intelligent life with radio. Wait, a radio signal. But this is saying it's a burst. Causing a radio wave. Okay. They expect that the most likely sources are neutron stars, since they are both very small and very energetic. I'll just read the last paragraph. I think it's the last. Thanks to some nifty cosmic detective work involving the data of other telescopes monitoring the same patch of sky, observational evidence is now suggesting that the origin of FRBs is very likely a magnetar, a type of young neutron star born from the embers of supernovas with a magnetic field 5 trillion times more powerful than Earth's, thereby making them the universe's most powerful magnets. Oh, that wasn't the last. bigger. Probably bigger. Red dwarf. Oh, it's yeah, red dwarf. Okay, I looked up, does a red dwarf become a neutron star? Because a red dwarf occurs when there's a nova or a supernova, and the energy is expended, and what's left of the matter collapses into a red dwarf, which has some heat and energy, but is actually a dying star. Brown dwarf stars, white dwarf stars, and even neutron stars aren't actually stars. While red dwarf stars, yellow dwarfs like our sun, and all giant stars do turn out to be stars, here's what makes all the difference. Well, dense, new letter energy, and powerful magnet. Okay, a neutron star is the collapsed core of a massive supergiant star which had a total mass of between 10 and 25 solar masses, possibly more if the star was especially metal-rich. Except for black holes and some hypothetical objects, neutron stars are the smallest and densest currently known class of stellar objects. Okay, the question is a black hole magnetic? The intensity of the light rays and their direction are what we observe with the Event Horizon Telescope. Black holes are enveloped in plasma. This plasma has magnetic fields, areas where magnetism affects how matter moves, threaded throughout. I'd never heard of the Event Horizon Telescope. I'd seen the movie. Huh. Oh, pardon me. Images. These are pictures of a magnetic field around a black hole. Some of the people here fear that they are becoming or have become neutron stars. Highly dense, highly magnetic.
There are spies everywhere, hiding it.
Neutron stars are one of the most extreme and violent things in the universe. Giant atomic nuclei only a few kilometers in diameter, but as massive as stars. And they owe their existence to the death of something majestic. Stars exist because of a fragile balance. The mass of millions of billions of trillions of tons of hot plasma are being pulled inwards by gravity and squeeze material together with so much force that nuclei fuse. Hydrogen fuses into helium. This releases energy which pushes against gravity and tries to escape. As long as this balance exists, stars are pretty stable. Eventually, the hydrogen will be exhausted. Medium stars like our Sun go through a giant phase where they burn helium into carbon and oxygen before they eventually turn into white dwarfs. But in stars many times the mass of our Sun, things get interesting when the helium is exhausted. For a moment, the balance of pressure and radiation tips and gravity wins, squeezing the star tighter than before. The core burns hotter and faster, while the outer layers of the star swell by hundreds of times, fusing heavier and heavier elements. Carbon burns to neon in centuries, neon to oxygen in a year, oxygen to silicon in months, and silicon to iron in a day. And then, death. Iron is nuclear ash. It has no energy to give and cannot be fused. The fusion suddenly stops and the balance ends. Without the outward pressure from fusion, the core is crushed by the enormous weight of the star above it. What happens now is awesome and scary. Particles like electrons and protons really don't want to be near each other. but the pressure of the collapsing star is so great that electrons and protons fuse into neutrons, which then get squeezed together as tightly as in atomic nuclei. An iron ball the size of the Earth is squeezed into a ball of pure nuclear matter the size of a city. But not just the core, the whole star implodes, gravity pulling the outer layers in at 25% the speed of light. This implosion bounces off the iron core, producing a shock wave that explodes outwards and catapults the rest of the star into space. This is what we call a supernova explosion, and it will outshine entire galaxies. What remains of the star is now a neutron star. Its mass is around 1 million times the mass of the Earth, but compressed to an object about 25 kilometers wide. It's so dense that the mass of all living humans would fit into 1 cubic centimeter of neutron star matter. That's roughly 1 billion tons in a space the size of a sugar cube. Put another way, that's Mount Everest in a cup of coffee. From the outside, a neutron star is unbelievably extreme. Its gravity is the strongest outside black holes, and if it were any denser, it would become one. Light is bent around it, meaning you can see the front and parts of the back. Their surfaces reach 1 million degrees Celsius compared to a measly 6,000 degrees for our Sun. Okay, let's look inside a neutron star. Although these giant atomic nuclei are stars, in many ways they're also like planets with solid crusts over a liquid core. The crust is extremely hard. The outermost layers are made of iron left over from the supernova, squeezed together in a crystal lattice with a sea of electrons flowing through them. Going deeper, gravity squeezes nuclei closer together. We find fewer and fewer protons as most merge to neutrons, until we reach the base of the crust. Here, nuclei are squeezed together so hard that they start to touch. Protons and neutrons rearrange, making long cylinders or sheets, enormous nuclei with millions of protons and neutrons shaped like spaghetti and lasagna, which physicists call nuclear pasta. Nuclear pasta is so dense that it may be the strongest material in the universe, basically unbreakable. Lumps of pasta inside a neutron star can even make mountains, at most a few centimeters high, but many times as massive as the Himalayas. Eventually, beneath the pasta, we reach the core. We're not really sure what the properties of matter are when they're squeezed this hard. Protons and neutrons might dissolve into an ocean of quarks, a so-called quark-gluon plasma. Some of those quarks might turn into strange quarks, making a sort of strange matter with properties so extreme that we made a whole video about it. Or maybe they just stay protons and neutrons. No one knows for sure, and that's why we do science. That's all pretty heavy stuff, literally, so let's go back out into space. When neutron stars first collapse, they begin to spin very, very fast, like a ballerina pulling her arms in. Neutron stars are celestial ballerinas spinning many times per second. This creates pulses because their magnetic field creates a beam of radio waves which passes every time they spin. These radio pulsars are the best known type of neutron star. About 2,000 are known of in the Milky Way. These magnetic fields are the strongest in the universe, a quadrillion times stronger than Earth's after they're born. They're called magnetars until they calm down a little. But the absolute best kind of neutron stars are friends with other neutron stars. By radiating away energy as gravitational waves, ripples in space-time, their orbits can decay and they can crash into and kill each other in a kilonova explosion that spews out a lot of their guts. When they do, the conditions become so extreme that for a moment, heavy nuclei are made again. It's not fusion putting nuclei together this time, but heavy neutron-rich matter falling apart and reassembling. Only very recently, we've learned that this is probably the origin of most of the heavy elements in the universe, like gold, uranium and platinum, and dozens more. So there now, 2 neutron stars collapse and become a black hole, dying yet again. Not only do stars have to die to create elements, they have to die twice. Over millions of years, these atoms will mix back into the galaxy, but some of them end up in a cloud which gravity pulls together to form stars and planets, repeating the cycle. Our solar system is one example, and the remains of those neutron stars that came before us are all around us. Our entire technological modern world was built out of the elements neutron stars made in eons past, sending these atoms on a 13 billion year journey to come together and make us and our world. And that's pretty cool. Until then, we can look at them on paper. The 12,020 Human Space Era calendar has arrived. You can order it now until we sell out, and then never again. Visit the cloudy cities of Venus, Dyson Swarm Assembly on Mercury, and cross the borders of our solar system. Shipping from the US and from Europe for the first time, but we deliver to every country all over the world. You could also get a plushie or hoodie or poster. We have some sweet deals for you. Get it for Christmas for your friends, families and kids, or to distract yourself from the fact that there are 100 billion Earth-like planets in the habitable zone of sun-like stars in the observable universe, and you will never visit any of them. The last few years we've sold them all, so no rush, but the clock is ticking. Getting stuff from our shop is one of the best ways to support Kurzgesagt. Because of you, we can keep this channel free for everyone and make more beautiful things. A happy interstellar year, 12,020.
I'm gonna download this. I mean, upload it.